Hello everyone and welcome to this walkthrough of my ApacheBeam data engineering project. In this video, I'll guide you through 3 different assignments that showcases various data engineering and visualization techniques. So this project is organized into 3 basic parts. So the first one is nothing but exploratory data analysis using D3.js visualizations. And then the second part is doing auto EDA with a tool. So I've used Sweetviz for this. And then the final part of the assignment, or the third assignment, is nothing but it is a comprehensive demonstration of Apache Beam features. So let's dive into the first part of the assignment. So in the first part of my assignment, which is nothing but or EDA, complete EDA using D3 visualizations. So what I've done is, so I focused on EDA using D3, and the goal of this part was to push the limits of conventional EDA by creating interactive visualizations that make sense, and there's some connection between like data and finding the patterns. So let me come back to my IPVNB. Okay, so here we have all of the code that I have for this particular assignment. So this is nothing but I was doing all the installation and everything, and for D3 visualization I've used Python and HTML. And then here I'm taking a data set. So here I have a global terrorism database that I got from Kaggle, and I have it in my local. So yeah, this is where I'm reading it, and then I'm checking if any null values are present. And then here just doing the percentage of the null values. So if you can see, most of these columns which has a lot of missing values, we mostly will drop them if they are more than 50% is the threshold. So if you see, I've set this threshold as 50, and then if the missing values are more than 50%, then they'll be dropped. So we got the clean data after that. So this is the EDA. This is where we do the EDA starts. So first is the outlier analysis. So created a box plot for all the outliers, like fatalities, wounded, and all the related features. And then this is a feature engineering where you modify the data to make more sense, or yeah. So here fatality rate and wounded rate columns are created to calculate rates per perpetrator. And then attack severity is a new feature that I have created. So if you see, attack severity is this feature which we've used nkill and nwound. So basically, like how severe the attack was. And then this is the univariate analysis, and this is a simple graph which shows like the number of terrorist attack over the years. And then this is another graph which is showing the number of terrorist attacks by region. Then this is where we're displaying the top countries which have the most terrorist attacks. And then this is the different types of terrorist attacks that have taken place. Then you can see how many successful terrorist attacks there were there. So yeah, casualties, and then all of the terrorist groups and number of attacks that they have done, and then the number of hostages. And then this is a correlation map between a few of the features. And I just have a few visualizations that I felt like make sense, and it's easier to understand the data like this. So if you can see, this is a graph of the fatality rate against the wounded rate by region, and all of these points are nothing but the regions. The legend is basically the region. And then trends in fatalities over the over time in the top 3 regions which are mentioned over here. And then this is where we come to the D3 visualization. So in this I have 2. So you can see top 5 countries by number of attacks. So this is one of the visualizations, and the other one which I have is attack severity by region. So it is an interactive visualization. Yeah. Okay, so I would like to continue on with the second part of the assignment, which is nothing but we performated like automated exploratory data analysis using Sweetviz. So it is like an auto ADA tool that we can use to do data analysis. So here, what exactly is Sweetviz? It is a powerful tool that generates reports like summarizing data distribution, correlations, and other key statistics. So this can be really helpful when we want to like quickly understand what the data set is before diving into projects. So I would like to go to the, I'm going to show the IPVNB now, the file. So here we have to install the Sweetviz dependency, and then here we have the Cbon, which is nothing um, for data visualization. And then this is a data set that I've used, Ultimate Spotify Track State DB, which I got from Kaggle. Then I have it in my local, and then so for this you just need to import Sweetviz, and then you just have to like pass the data frame to that particular analyze, and then you can directly ask it to show like show the report, or you can directly save it to your Google Colab. So for this database, this is the report that I've got. You can see it has 2000 or 2,32,725 rows, and yeah, these are all of the categories that it has, or like the features it has. You see, automatically it'll create all of the like graphs, charts, etc., that you need to understand your data a bit more. If you can see, these are all the features that are present, and it just directly creates a report for us so that we don't have to worry a lot about the exploratory data analysis of the database. So yeah, this is all about the assignment too. On to the final part of the assignment, which is nothing but using Apache Beam, or like demonstrating Apache Beam features. So this is where I demonstrated like various features of the Apache Beam, which is nothing but it's a powerful tool for for building data pipelines. So Apache Beam is particularly useful for handling large scale data pre-processing and streaming tasks. So in this particular assignment, I've showcased several features like composite transforms, pipeline input output, windowing, triggers, and Pardo transforms. So this combination of features is what it makes Apache Beam an ideal choice for both uh, batching and streaming data applications. So moving on to our, so the first thing is you install Apache Beam, and I had some dependency, so I had to install that too. Oh, yeah, installing everything. And then this is nothing but it's a basic Apache Beam pipeline where I'm like reading from the input, splitting the words, and then writing to an output text file. And this is where we're doing the composite transform. So this is for the windowing and the triggers part. So if you see, we have the window into. So nothing but just creates 10-second windows over here. And then this is where we have the output. It is there in my GitHub repo, so you'll be able to see that. And then this is where I loaded the iris dataset, and I chose like two features for model training, and then I trained the model using the random classifier model, and then I saved it. So based on the two features, I created a pipeline, and then using write to text and then using sklearn, like pardoing on the sklearn interface, I was able to like make the prediction of whether uh, the iris, the petal or the leaf, sorry, the flower is of what category. So this is where I included another two features, and then defining the pipeline with the same four features, and then doing the same prediction on that. So yeah, I have all of my files in this particular GitHub repo. Then you'll also be able to see all of the outputs that we got from all the models and the predictions in the Apache Beam. So for this, I would like to conclude by saying that so this project I basically demonstrated various approaches to do data engineering, from like detailed EDA with D3 visualizations, and also like making it easier for us by using something like Sweetviz, or there was another option over here. Yeah, Pandas profiler to just automatically do exploratory data analysis, and then also like data processing with Apache Beam. So yeah, thank you for watching.